This is Derek Thompson, and I'm doing exercise 37 in section 1.2 of the Stewart calculus book. And the problem here, they want you to take these two functions and add them, subtract them, multiply, and divide and find their domains. I'm going to do the subtraction and the division. Hopefully you know that the sum or difference or product of polynomials, like you see here, creates another polynomial, and you should already know that all polynomials have the domain as all real numbers. However, division makes a rational function, which is different, but I'm also going to do subtraction first because there's a bit of a subtlety here. So let's go to the next page and let's write these functions again. F of x is x cubed minus 2x squared plus 2x squared, and g of x is 3x squared minus 1. Now, if I want to create the function f minus g, I just subtract the two functions, but you have to realize that subtracting a function means you subtract all of it. So, I write f, again, x cubed plus 2x squared, and then I subtract all of the function g, which is why I'm going to use parentheses here. Generally, it doesn't hurt to have too many extra parentheses as long as you know where they go. So now I can distribute the negative here. So I've got x cubed plus 2x squared minus 3x squared plus 1. And so that's x cubed minus 1x squared plus 1. So we have x cubed minus x squared plus 1, and like I said at the beginning, subtracting, adding, or multiplying polynomials gives you another polynomial. So this is the polynomial f minus g of x. So f minus g is what we call the new function. And so its domain is all reals. And so for interval notation, we just write minus infinity to infinity. Okay, so that was part B. Now for part D, we're going to divide the two. So again, f of x was x cubed plus 2x squared, and g of x 3x squared minus 1. So dividing simply means that I write one over the other, and f of x will be in the numerator here. So this is x cubed plus 2x squared, and then the denominator becomes 3x squared minus 1. However, this is now a rational function, not a polynomial, and because we have a denominator, we have to worry about when is that denominator 0. And so this is the final answer for the function, but I need to figure out the domain by checking when is that denominator 0. So if I set 3x squared minus 1 equal to 0 and solve for x, I'll add 1 and divide by 3. And so I get x squared equals 1/3. And now I need to take the square root. And when I take that square root, I get x is plus or minus the square root of 1/3. Some of your teachers might have had you rationalize 1/3. I'm not too concerned about that. However, I need to exclude those points from my domain.